Welcome to the lecture. In this lecture, we will see what is meant by matrices, how to create matrices in Python, and also how to check dimensions of the matrix. We will also see how to modify elements in the matrix and how to access the elements, and also the sum of the matrix operations which is available in Python. Let's get started. So first we will see what is meant by a matrix. Matrix is a two-dimensional data structure consisting of numbers in rows and columns. Rows runs horizontally and columns runs vertically. First we will take a matrix. So this consists of 9 elements. So it runs from A112, A12, A13. So this is the first row. And second row it consists of elements of A21, A22, A23. Similarly for third row. We will take another example. So this one is a 3 cross 1 matrix, which means 3 rows and 1 columns. This one will be a 1 cross 3 matrix, which means 1 row and 3 columns. Let's see how to create a matrix in Python. Matrix is a command to create a matrix. So it basically returns a matrix from the array type object. So the syntax is you have to import the NumPy package. So from the NumPy package we will call the function called matrix. Inside the parenthesis you have to specify the values for the matrix. Before creating a matrix we will first import the NumPy package as NP. Now we will create a 3 cross 4 matrix, which means 3 rows and 4 columns. So since we have already imported NumPy as NP, so I will call hereafter NP from NP dot matrix. So inside the parenthesis we need to specify the values, right? I am giving values 1, 2, 3, 4. After that 4 you can see there is a semicolon, which means so we have filled the values for the first row. 4, 5, 6 till 7, and after 7 again you can see a semicolon. So which means we have filled the values for the second row. Similarly you can give values for the third row. Any values can be given to create a matrix. We are storing a matrix in the variable called A. When we print A, so it has created a matrix with 3 cross 4. Let's see some of the matrix properties. So if you wanted to know the number of rows and columns, then you can use the shape command. So you have to specify the matrix name followed by dot shape. So it basically returns the number of rows and number of columns. Let's say if you wanted to get the number of rows alone, then you can use the shape. Inside the square brackets you can specify 0. So 0 is basically for rows and 1 is basically for columns. So shape of 1, it basically returns the number of columns in the matrix. So A dot shape of 0, it basically returns the number of rows. So in our case we have 3 rows. Similarly, if you wanted to extract the number of columns, then you can use A dot shape of 1. So in our case it returns a value 4, which means 4 columns are there in the matrix. Let's say if you wanted to extract the number of elements in the matrix, then you can use the size command. So we will again use the matrix A dot size. So since it is a 3 cross 4 matrix, so you will be getting a 12 elements in the matrix. Let's see how to modify the matrix using some of the built-in functions which is available. So first we will use the insert command. So insert, what it does is it adds the values at a given position, and also you can specify the axis as well. So the syntax is NumPy dot insert. You have to specify the matrix, which is the input matrix, and then the object, which means the index position, at which index you need to insert the matrix, and the corresponding values, and then the axis. So axis is equal to 0 is for rows and axis is equal to 1 is for columns, along which axis you need to insert the matrix values. So first we will add the matrix column underscore new as a new column to the existing matrix, which is A. So first we'll create a matrix column underscore new and we'll supply some values column underscore new. So in that it has values 2, 3 and 4. So when you print it, so it returns the values which you have declared earlier. Let's see how to insert this matrix to the existing matrix A. So np.insert. So the A, which is the existing matrix, you have to specify the old matrix, and if you wanted to index, you have to specify the index position, at which index position you need to insert the matrix. So here I am specifying 0, which means it will be inserted at the 0th index position, and then the new matrix which we have created now, column underscore new, and if you wanted to insert along the columns, you have to specify axis is equal to 1, and I am storing it back to the same matrix A. Now let's see what is the output when you print A. So now it will be inserted at the 0th position. So you can also insert at the first position, first index position or the second index position as well. Let's see how to add a matrix along the row wise. So first we will create a matrix row underscore new and we will add it as a new row to the existing matrix A. So in the A matrix, so now the dimensions will be 3 cross 5, right? So we need to supply 5 values for the row matrix. So np.matrix, so inside the parenthesis I am specifying the values for the row matrix and storing it in a matrix row underscore new. When you print, 4, 5, 6, 7, 9 will be printed. Let's see how to add this matrix to the existing matrix A. So you can use the np.insert command. So the existing matrix A, and here also I am adding at the 0th index position, and then the matrix which we have created now, which is a row underscore new. Since we wanted to add along row wise, you have to specify axis is equal to 0. I am storing it back to the same matrix A now. So let's see what is the output. So when we print A, so now the dimensions will be changed. So we already add 3 cross 5. Now the dimensions of the matrix will be a 4 cross 5 matrix, which means 4 rows and 5 columns, and the matrix has been added at the 0th index position. So 4, 5, 6, 7, 9 has been added along the row wise at the 0th index position. Let's see how to modify the matrix using the index number. So I am going to print the matrix A. So this is our matrix. Now the dimensions is 4 cross 5. So let's say if we wanted to change the value of 1 to -3, so we can change the elements of matrix using the index number. So you have to specify the matrix name A. So the row index is 1 and the column index is 1. So you have to specify the index numbers. So 1 corresponds to the row index and this 1 corresponds to the column index. Since we wanted to change to the -3, I am specifying here. So let's see the modified matrix. We will print the updated matrix. So this will be our updated matrix. Now the value of 1 has been changed to -3. Next we will see how to access the elements of the matrix using the index number. So first we will print the current matrix, which is our A. So after modified, so this is our current matrix, which is of dimensions 4 cross 5. Let's say if you wanted to extract elements from the second row, you can access using the index number. So if you give print of A followed by the row index, so the second row corresponds to the index number of 1. So 1 comma colon, which means takes all the columns corresponding to that index. So once you have done this, so we will get an output of 2, -3, 2, 3, 4. Let's say if you wanted to extract from the third column, then you can do that as well. So you have to specify the index number for the row index and for the column index. Here we wanted to extract from the third column. So the third column corresponds to the index position 2, colon comma 2. So if we wanted to extract elements from the third column, so the corresponding index number is 2. So we wanted to extract those rows, corresponding rows as well. So that's why we are specifying colon. So we will be getting an output of 6, 2, 5, 8. So these are the values for the corresponding third column. If we wanted to extract a particular element using the index number, you can also do that as well. So let's say we wanted to extract element corresponding to the index of 1, 2. So when you specify print of A, so first is row index 1, 2. It returns an element 2. So till now we saw how to create a matrix and some of the modifying operations. Let's get started with matrix operations. So there we can also do addition, subtraction, multiplication, division as well. So let's see one by one. So first is matrix addition. The command is numpy.add. So what it does is it performs the element wise addition between the two matrices. The syntax is numpy.add. So inside the parenthesis you have to specify the matrix 1 name and followed by the matrix 2. So we will create a 2 matrix A and B. So A. So before calling the np.matrix, you have to import the numpy package. Import numpy as np and then you can use the command np.matrix. Here I am giving the values 0 to 19. So using the arange command. So we already saw what arange does, and dot reshape I am specifying the row dimensions and column dimensions. Similarly, you can create a matrix B. Here I am giving the values 20 to 40. So the same dimensions, so which is 5 rows and 4 columns. So let's print A and B, both the matrix. So when we print A, it has created a matrix with 5 rows and 4 columns. Start value 0 and till the end value 19. Similarly, when we print B, so it has created a matrix with 5 rows and 4 columns. The start value is 20, 21, 22 till 39. So let's do this matrix addition for this both the matrix A and B. So np.add A, B. So we will be getting an output. So it adds element wise. So it adds 0 plus 20 and next one will be 1 and 21. So you will be getting an output like this. So 20, 22, 24 and 26, etc. Next we will do the matrix subtraction. So numpy.subtracts, it performs the element wise subtraction between the two matrices. So the syntax is numpy.subtract. Inside the parenthesis, you have to specify the matrix 1 name followed by the matrix 2 name. So we will consider the same matrix A and B which we have created earlier. So A, this one is A. So we use the values from 0 to 20 and B, these are the values. So let's print A and B. So this is our matrix. So for this matrix, we will use the matrix subtraction. So the command is np.subtract. Inside the parenthesis, you have to specify the matrix A name and the followed by the matrix 2 which is B. So when we print the matrix, output will be minus 20 for the first one. So it is 0 minus 20. So we will be getting an output of minus 20 for the second element. So it is 1 minus 21. So it is again minus 20. So for all elements we are getting minus 20. Next we will do matrix multiplication. So numpy.dot, it performs the matrix multiplication between the two matrices. So the syntax is numpy.dot. Inside the parenthesis again you have to specify the matrix 1 name followed by the matrix 2 name. So we will consider the same matrix A and B. We will print again A and B. So this is a A matrix and this is a B matrix. So we will use the numpy command for matrix multiplication. So np.dot A, B. So it does the matrix multiplication. Matrix multiplication in sense, so it takes first row wise and next For the B matrix, it takes along the column wise. So it multiplies 0 into 20 plus 1 into 24 plus 2 into 28 plus 3 into 32. Let's see what is the output which you are going to get. So it throws up an error, value error, shapes 5, 4 and 5, 4 not aligned. Yes, for the A matrix we have the dimensions 5 cross 4. For the B matrix we have again 5 cross 4. For the matrix multiplication, so the one rule which we have to follow is number of columns in the matrix A, it's basically should be equal to the number of rows in matrix B. So since 5 cross 4 for matrix A and 5 cross 4 for matrix B, when you compare the number of columns in matrix A is not equal to the number of rows in matrix B. So that's why it has thrown up an error. So now what we will do is, we will transpose this B matrix to make it a 4 cross 5 in dimension. So for that we will use a command called np.transpose for the B matrix, and we will store it back in the same matrix B. So when we perform the matrix multiplication for this matrix, now we will be getting an output. Yes, now our A matrix is 5 cross 4 and now we have changed the B matrix to 4 cross 5. So the dimensions are equal. So now it gives an output. So it is 134, 158, 182, 206, 230, etc. So you can also use numpy.matmul and also the at operator. It can be used for the matrix multiplication as well. Let's say if you wanted to perform element wise multiplication, then there is a command called numpy.multiply. It performs the element wise. Syntax is numpy.multiply. So inside the parenthesis you have to specify the matrix 1 name followed by the matrix 2 name. So this is a matrix which we have created earlier before transposing. So this is our A matrix and this is our B matrix. Now we will perform the element wise multiplication for this both the matrix. So the command is np.multiply of A, B. So it has been multiplied. So 0 into 20, then it will be 1 into 21. So you will be getting an output of like this: 0, 21, 44, 69 and etc. Let's see how to do the matrix division. Numpy.divide, it performs basically the element wise division between the two matrices. So the syntax is numpy.divide. Again you have to specify the matrix 1 name followed by the matrix 2 name. So we will consider the same matrix A and B. So this is our matrix which we have created earlier and this is our B matrix. So let's print A and B. So A has values 0, 1, 2, 3 till 19 and B has values 20, 21, 23 till 39. So both are 5 cross 4 matrix. So we will perform an element wise division. So the command is np.divide A, B. So it has to return values when we print. So we will be getting a value like this. So first it takes 0, first element of the first matrix and first element of the second matrix. It is 0 divided by 20, 0, and next one is, it will be 1 divided by 21. So it performs element wise. So let's summarize. So first we saw how to create a matrix. So you can use a command called matrix. So before creating a matrix you have to import the numpy package. And then we also saw some of the matrix properties. So the shape, it basically gives the number of rows and number of columns. Size, it basically returns a number of elements in the matrix. We also saw how to modify matrix using the index number. So if you wanted to access a particular element or row or a column, we saw how to access the elements using the index number. And we also saw some of the matrix operation, which is addition. For addition you have to use the numpy.add. For subtraction it is numpy.subtract. For matrix multiplication we saw numpy dot dot. So if you wanted to perform element wise, you have to use numpy dot multiply, and we also saw division, which is numpy dot divide. So these are the matrix operation which we saw.